closed-toed shoes, obviously, can't really tell it's a full body suit, and a chemical hood. We only have a small chemical hood on campus, but since we mixed a small batch, that was enough. In the future, a larger chemical hood would be required if the experiment was to be run indoors. If it was to be run outside, the ventilation will take care of itself. However, if the experiment wants to be run outside, you need to have some sort of a chemical shower or eye wash station right outside by the reactor, which is also something that we do not currently have on campus, which was one of the reasons we couldn't run our reactor outside, even though there was plenty of ventilation there. Another thing that kind of goes along with the safety is what happens if you spill something? What happens if you spill one of those chemicals that we just mixed? Or what happens if you spill the used vegetable oil? The cleanup itself would be considered a cleanup of a hazardous material, which falls under certain OSHA regulations that the school doesn't currently have. I'm not sure how to explain that properly without getting legal and technical about it. So Dean Madler agreed to allow us to go ahead and proceed with our run using water, just as a proof of concept, so we wouldn't be endangering ourselves, our fellow students, and the campus. In the future, we are hoping that AC2 would have a facility that could house and run this reactor inside. And now on to recommendations to Brian and Will.
Thank you, Sophia. So, as we have many further developments that can happen to this project, a few recommendations that we had was a stand of improving the stand in general. Since it's wood, it's a little unstable. It will sit on a flat surface and stay there efficiently, but if we move to a metal stand, it will become more stable and have a longer lifespan, less likely to crack and so forth. We'd probably keep the same, I'd recommend keeping the same T-frame. You can also move to a possible A-frame for equal support as you go for the load itself. And then another thing would be ankle braking. We looked at doing this with disc brakes, and since we're not moving anything, it'll only be a locking system. If we can just clamp it into place, it should be enough to hold it there. And then, if possible, because of weight, when we move to metal, we might want to look at having it be able to be moved with a forklift, since we have a couple on campus. Or we could possibly put casters on it, depending on where it was being moved to. And I'll pass it off to Caleb for a little bit on controlling.
Thank you, Brian. As I mentioned earlier, one of the great aspects of this design is that it can run continuously. It's a continuous flow reactor, and that requires some automation on its part. And right now, it's set up programmably to be run continuously. The data acquisition board is capable of doing such. And what it needs is some electronically controlled valves, electronically controlled heater, and a glycerol depth measurement. Now, this is obviously, it's too much for one semester for our team to accomplish, so it would make a great controls problem in the future, because that system is lossy and works well on needs to be controlled using a gain and system like that controls. And that's basically all there's on advanced control. So I will hand it off to William to talk about final possible stuff.
All right, so we were given a budget of about $6,000 to use. This is a spreadsheet of what our final budget looks like. There's a lot of information going on. But our total expenses came out to $4,397, so we were effectively under budget with all that stuff. All right.